After covering variables, operators, and all these core basics that you need to know in JavaScript, and actually in most programming languages, there is another important block or set of features which you will also need in basically any programming language you're going to learn, JavaScript included, and that would be control structures. Now that's kind of a strange term. What does control structures mean? It means that when you're writing code, you don't always want to execute exactly the same code top to bottom. Sometimes you have some condition that should be met for some code to be executed and execute some other code if the condition is not met, or you need to repeat some code execution. And instead of writing every cycle on your own, you can use some built-in features built into JavaScript to run through a code snippet multiple times until some condition is met or until some data is exhausted. So that's exactly what we'll have a look at in this module. To be precise, we'll have a look at conditional statements, if statements. You might have heard about if statements if you worked with some other programming language in the past. And we'll also have a look at conditional expressions. We'll therefore also have a look at another very important related topic, and that would be Boolean values and operators that help you generate Boolean values, which turn out to be rather important in if statements and conditional expressions. And we'll also have a look at loops and how you can run the same code with different data maybe multiple times with help of the many loops that are available in JavaScript. Last but not least, after having a look at loops, we'll also dive into error handling, and that will be different from what you learned in the debugging section. As you will learn here, I'm talking about errors which you can't avoid that might happen in your program as it executes, and how you can then react to them and what you can do to still fail gracefully, maybe show an error message to the user, or even fall back and make sure that your program works even though an error occurred. So these are all very important control structures, and with that, let's dive right into them. I want to start with conditional code execution, which is super important. For one, there are quite a lot, of cases, of scenarios, which you couldn't really solve or couldn't really handle without the availability of conditional code execution, so without features that help you run code based on certain conditions. The app we built thus far could be built without conditional code, but that's not the case for all apps. And in addition, even if you can build an app without conditional code execution, like our basic calculator, you can still often write cleaner code, shorter code, if you can run certain parts of your code conditionally. Now, what does conditional code execution mean? Imagine that you have a function, and conditional code execution is not just available inside of functions, by the way, but consider that you have a function, and in there you have two code snippets that you could execute. For example, you either add two numbers or you subtract two numbers. You do that in the same function, and of course you could write two separate functions, but even then you might want to call one of the two functions based on some condition. And that's exactly what conditional code execution is about. You might have some program where you either want to run option A, so want to add two numbers, or you want to subtract two numbers. So you have some condition that needs to be met, and for this you can use a so-called if statement. If statements are a core construct, not just in JavaScript, but actually in any programming language you can learn. Now, if statements require conditions. You specify a condition that must be met. And a condition is in the end just a Boolean value. You remember that strange Booleans part I mentioned earlier in the course? Well, that's becoming important right now. This was this special kind of value which could only be true or false. But that's exactly what you need in a condition, because a condition executes code A if it's true, or code B if it's false. Now, since a condition in an if statement wants in the end just true or false, you can always pass in a variable that holds true or false into that condition part. So you can always add if and then just check that variable and the value in there. That is possible, but you will not always have a variable that holds true or false. You will need to create that, and more often than not, you'll work with different kinds of data. Let's say you have some user input, which is a string, or you're working with some numbers, the result of a calculation, and therefore often you need to dynamically derive a Boolean value, and you can do that thankfully with the help of some Boolean operators, also known as comparison operators. Because these are operators built into JavaScript, just like plus, minus, the times operator, and so on, which don't yield a new number or a new string as a result, but which instead return or yield true or false. And there you, for example, have the equality operator. This double equal sign operator, and that's important, these are two equal signs. The single equal sign was used for assigning a value to a variable or constant. The double equal sign operator is used to compare two values and then return true or false. And you use it to check for value equality. So for example, you compare the variables a and b, and if they hold the same value, this would yield true. So you could use that comparison here in the condition or as a condition in an if statement. Of course, you also can check for values not being equal. You do this with the exclamation mark in front of the equal sign. And important here, you only have one equal sign. So the other equal sign is basically replaced by the exclamation mark here. This checks for value inequality, and therefore you could check if a and b are not equal and only execute some code if that's the case. Now there also is a special form of these two operators. You also have the equality operator with three equal signs, and therefore also the not equal operator with an exclamation mark and two equal signs. Now what's the difference to the first two operators I showed you? Well, the triple equal sign operator checks for value and type equality, or with the exclamation mark for inequality. Now what's the difference here? To find out, let's just dive here in the console in the browser developer tools on any web page of your choice, like our calculator, but that really doesn't matter. And in there, you can quickly play around with these operators. Now let's start with the double equal sign operator. Let's see what the result is if I compare 2 to 2. Now of course we get true as a result because these two values are equal. Now, needless to say that in your program, of course, you won't hard code a comparison like this. That's redundant because that will always yield true. Instead, you might be comparing two values entered by the user, for example, with the input like this, where you don't know the value in advance. I'm just using hard-coded values here to show how these operators work. So this yields true, but you also get true if you compare 2 to a string that holds a value of 2. And that's what the double equality operator does. It checks for value equality only. It doesn't care whether the two values you are comparing are of the same type. That would be the case with triple equal signs though. There, for two numbers being compared, if they have the same value, we get true. But if I compare this to a string with the value 2, I get false. So that's the important difference here. And the same, just the opposite, of course, is the case with the negation, so with the exclamation mark. Now, typically in JavaScript, you should prefer the triple equal sign or not equal operator over the double equal sign or not equal operator, simply because it forces you to write better code. You should care about the types of values you're working with. For example, if you're checking some user input and you're comparing it, whether it's equal to some number, well, you should first convert the user input to a number so that you can use the triple equal sign operator. It makes your intentions clearer, and it also avoids cases where a user might not enter a number at all. It would be better to then handle that case before you use the number instead of just getting a false result in a condition here. So typically you want to use the triple equal sign operator just because it forces you to write more explicit and clearer code. Now, of course, you can also not just check for equality or inequality. You can also compare numbers for being greater or smaller. So that's also available where you can check if number A or input A is bigger or smaller than input B. Now, both the equality and the greater than and so on operators can be used with numbers, but also with strings, Obviously, you can compare two strings for being equal, but you can actually also use the greater than operator, for example, with two strings to check if one string is greater than another string in a lexicographic way, which means C would be greater than A, because it's greater than A in an English dictionary. Now, besides greater or smaller than, you also have to combine greater than or smaller than or equal operators, which allow you to compare values for being smaller or equal or greater or equal, which of course makes sense because sometimes you want to include the value in the comparison and not just check for whether the other value is greater or smaller. So these are the core Boolean operators you have. The exclamation mark operator is also important to highlight. You saw it, of course, here with the equality checks. There we can combine it with the equal signs. Now you can also use it on a value where you already know that it holds a Boolean, so on a variable where you know that it stores a Boolean, let's say, to negate it, so to check if that is not true. This might sound a bit strange right now, because you typically create Booleans with the other operators, and if you wanted to negate it, you could just, well, use the unequal operator. But you will find cases all throughout the course where you have some value which you derive as a Boolean in some part of your code, and then in some other part of your code, you need that value again, so which already is a Boolean, and you just want to then run code A if that was true, or code B if it was not true, and then you can just use that exclamation mark operator to do that. Now again, we'll see all of that in action in this course and in this module here already. This is just the overview. And with that overview out of the way, let's actually see a concrete example for how we write a if statement and how we use some of these operators in there. For this, I want to reuse the calculator, and attached you'll find my version of that calculator, the one we finished in the basics module. You can of course also use yours or just download and use mine to have exactly the same code. And in there, I want to give you an example of how we could use conditional expressions to optimize this code a bit more. Because of course this works without any if statements, clearly, because we haven't learned about them yet. But you might notice that in the add, subtract, multiply, and divide functions, we have a lot of code duplication. We always start by getting the entered number, then we set the initial result, that's always exactly the same. Then we have our calculation, which is always different. Then, however, we again just write the output or write to the log, and yes, we do pass different information in there, but actually the only information that is different is the operator that we used and the description of the operation we did. The other parameters are always the same. So there is a lot of code reusage, but without conditional statements, without if statements, there really wasn't a way around it. Well, now this changes. Now we can, for example, add a new function here, maybe just name it calculate result, something like this. And there I'll bring in my code that I have in the add function. But here I now want to write this in a more flexible way. Here I can now expect a parameter, let's say calculation type, and I expect this to be a string that describes the type of calculation we want to perform. Now we can add an if statement here by just adding if, this is a keyword understood by JavaScript, then parentheses where we place our condition in, and then, important, curly braces. Now this here, the parentheses here, that will take our condition. The parentheses here will in the end take our body, our code that should be executed if the condition is met. Now you don't add a semicolon after this, just as you didn't do it for the function here. And now we need to add a condition here. Now the condition could be that calculation type is equal with the triple equality operator here, equal to, let's say, add. If that is the case, then I want to set current result equal to current result plus entered number. And now I also want to provide an alternative to that, and we do that with the else keyword. Now you add that right after your closing curly brace for the if block, so for the if the condition is met block. And then you add another pair of curly braces that now marks the block of code that should be executed if this condition is not met. So if the condition is met, we make it into this first block, and therefore this code gets executed. The other code is ignored, so the code in here is ignored. If this condition is not met, then we'll ignore this code, and instead the code in here will get executed. And therefore, now let's say we want to subtract. Later I'll also cover the other cases, but for now let's say I want to subtract here. So I will just move that subtraction code in here. Now you can also, by the way, write this like this, for example. So move else onto a new line. If you only have one expression you want to execute, you could also omit the curly braces here. That would be allowed. But for readability's sake, I recommend that you always add curly braces, even if you have only one expression in there. And you also most often will find a style where the else statement or the else keyword then is on the same line as the closing curly brace. So whilst this would work, my code formatter even moves it back to this line if I auto-format the code, because this is the most common way of writing this, which you will find in most resources you find on the web, and therefore this is the style I would recommend to you. We also use indentation here to improve readability. Technically, that's all not required. Technically, just as with the functions, you could write this all in one line like this, but of course that would be super hard to read, which is why we split this across multiple lines. So now we're performing different calculations based on the calculation type we're getting. Now I also want to write my output here based on that. And for that, let me actually check for add here, all capital case. So now calculation type could be forwarded here. Now this all of a sudden is way more dynamic. It has no hard-coded values in there. Instead, this is now fully reusable because all these values are dynamic. We therefore get a different result by just tweaking these values. And now here, for the plus operator, well, we just have to introduce a new variable here, math operator, for example, which by default has no value. But then here in the add case, I set this to be equal to a plus, and now just with one equal sign, because here I'm not checking two values, I'm not comparing two values. Instead here I want to assign this as a value to the math operator variable. And in the else case, math operator simply is a minus. So that's just a string, of course. And I'm using that because now I can use math operator down here. And now these two lines are fully reusable. They have no hard-coded values in there, and therefore they work for whatever the calculation we're performing. We just have to make sure we set these values correctly. Now, calculation type should be received from outside, and therefore what we can now do is here in the add case, we can remove all that code and instead call calculate result and pass in add as a calculation type. And for subtract, we also remove all of that, and I pass in subtract, or for now actually any other value than add will do the trick. Because if we pass in add, then this function will be executed and calculation type is set equal to add, which means we make it into this block here, we make it into this block, this code gets executed, and therefore we do the same which we previously did in here in add. We add the numbers, we set math operator to a plus, and therefore down here we forward add as a value for calculation type and a plus here for math operator. If anything else then add is received, we currently always subtract the values here in the else block, and math operator is set to a minus, so here we'll pass in whatever value calculation type held, and the math operator will be a minus. So if we save that and we reload our calculator, you will notice that it works exactly as before for all these operations, and most importantly also for plus and minus, where we now reuse our code with the help of this if-else statement. Now what you're already seeing in the example I showed in the last lecture is that of course this if-else statement in the end allows us to write more reusable code. Now calculate result is a function that works both for addition and subtraction. But you also see that two cases aren't enough here. I'm not happy with just two cases. We could also be multiplying or dividing. Well, the good thing is, besides if and else, you also have else if. You can use else if to add yet another condition you want to check, and you can have more than one else if statement here. An alternative would be a nested if statement where you now have a if statement in the else statement, so that if this condition is not met, you can check another condition, but you quickly end up with deeply nested if statements in if statements in if statements if you add more and more if statements in if statements, and that can make your code harder to read. So you would typically use such an else if statement here, where you can check for another condition here. So here I could check if calculation type is equal to subtract and then execute this code. And therefore right now with this code, if calculation type is add, we run this code. If it's subtract, we run this code. If it's any other value, that's also okay, but then neither this code nor that code here runs. So in that case, none of that code executes. And this means that right now this function wouldn't really work because that down here would be kind of broken. But technically you can also have if statements in your code where you don't necessarily meet any condition. That might be okay. It really depends on which kind of code and program you're writing. Throughout this course, you will also see examples of if statements where we also have the scenario that no condition is met. If you specify an else case, however, by the way, you are guaranteed that this code will always run if no condition was met in advance. So you don't need to have an else block here. Then it might very well be the case that no condition is met and no code runs. If you have an else block, on the other hand, then the else code will always run if no condition is met in this if statement. This is how if statements work. Now, however, here, I'm not just interested in adding and subtracting. Instead, I'll add another else if statement and check if the calculation type is equal to, let's say, multiply. If it is, well, then I want to take this multiplication code from down there, so set current result equal to current result times entered number, and set the math operator equal to this asterisk here. And now we can add a normal else block and just perform the division here because this is our last case. Of course, we could also use another else if block. That really depends on how you want to do that. If you just add an else block here, this means that this code runs no matter what is passed in as calculation type. So even if it's not divide but hi, I'm Max as a text, we would still execute this. This might or might not be what you want. If you want to make sure it really is divide here, then you would have to add calculation type equal to divide. So now you would just run this code if calculation type is divide. If the calculation type is neither add nor subtract or multiply or divide, none of the code would run. So that's really up to you. Here I'll go with the explicit check, but you could also just use an else statement here since we check all other options in advance. Well, and now we just have to make sure that we call calculate result. So call it here when we multiply and pass in multiply as a value, of course. And here for the division, pass in divide. And now we have way more concise and shorter code with our code reusage. We have all the logic in one function, which is good because it means we don't have to check dozens of functions to understand our code. Instead, it's all in here. And we have very lean code in here. Now let's just quickly validate this by running some calculations here. And we seem to have a problem with the multiplication. Yeah, because I have a typo here. This should be multiply. So let's fix that and reload. So now multiply this. Yeah, this now looks way better. And with that, this is the basic introduction to if statements and how you write them and how you use Boolean operators. Now, of course, here I always use the equality operator because equality is the thing I'm interested in here. This is not really a use case where I would use the greater than operator or anything like that, but we'll also see use cases for that throughout the course. And of course, you can also play around with your own basic if conditions and try them out with some numbers and some greater than comparisons if you want to. Again, this also is something, though, we'll have a detailed look throughout this module and throughout the entire course again. When comparing values in JavaScript, there is a strange behavior you might notice if you start comparing objects and arrays to each other, because these don't work like numbers or strings do. Consider this example. You have an object which has a name property which holds max as a value, and you have another object which has the same value. Now, these are not the same object. We're not talking about one variable here which I want to compare to itself. That would be redundant. But instead, let's say these are two different variables with two different objects. But of course, the objects themselves, regarding the values that are stored in there, are kind of equal to us humans. Now, still, if you compare these, no matter if with the triple or the double equal operator, you will find out that the value is not true as you might have expected, but instead that it's false. Now, why is that? Because objects and arrays, and for arrays it's indeed the same. If you had two arrays with the same values, they would not yield true if you compare them with the equals and operators. For objects and arrays, you have to understand that they're kind of special in JavaScript. Now, I'll dive deeper into what exactly is special there later in the course, where we have a closer look at the technical details of JavaScript and some of the core things you also have to be aware of. For now, let's just keep in mind that these two types of data, objects and arrays, are special. And we can again check this by opening the console in the developer tools, here again in the calculator, but that does not matter. And in there, let's create two constants or variables, doesn't matter. Person1, which is an object with name max, so with a name property that holds a string. And then person2, which basically holds the same data. Now, if you now compare person1 to person2 with the equality operator, again, it doesn't matter if you use 2 or 3 equal signs here, you see you get false as a value here. So this generates a boolean of the value false here, not true. Even though to us humans this looks exactly the same. Now, it has something to do with how that is stored behind the scenes in memory. But again, we'll dive into the details of that a bit later. For now, just keep in mind that two objects stored in different variables will never be the same. It's different if you have an object stored in a variable or constant, and then you create a new constant or variable, let's say person3, which you set equal to person1, then you will see that person3 is indeed equal to person1. But if you have another constant or variable where you assigned a brand new object, which you created like this and then assigned like this, then this will never be equal to an equal looking but differently created object in another constant or variable. So that's just something to keep in mind. Again, why this is the way it is something we'll have a detailed look later. It's also the same for arrays, as I mentioned. If you have your hobbies array here, and it includes sports and cooking like this, and then you have more hobbies, and that has exactly the same values written in exactly the same way, then here also you will find out that hobbies in this case is never equal to more hobbies, no matter how many equal signs you use, just as it was the case with objects. Also because arrays behind the scenes are objects, as you learned earlier. So again, why this is the case will be covered later. For now, just keep it in mind, equality comparisons won't work like this for objects and arrays. You would have to compare individual values. So for example, person1 name equal to person2 name. Since you then get access to the string that's stored in there, this again would work. So this is a comparison you can make, but the overall object or array, that can't be compared. Now, sometimes when writing an if statement, you want to combine conditions. There's not just one condition which has to be met to execute some code, but maybe two. Or you got two alternative conditions. So let's say we have three conditions in our code that should be met in an if statement. The first one is that name is equal to max. The second is that the age is 30. And the third one is that the isAdmin flag is set. So this could be a Boolean value which is set to true. For this user, it's always set to true, for example. Now, maybe you want to combine these conditions. Maybe you want to say, if condition A is met and B is met, then I want to execute the code. Alternatively, if the user is an admin, I don't care about A and B, so I always want to execute some code if his admin is true. So then you could say A and B should be met together, hence the AND, or condition C is met, and translated into code that you can write in JavaScript, and is represented with the double ampersand operator, or is represented by the double pipe operator. So in that case, the condition A and B would be evaluated together, and only if both yield true, this combined condition here yields true, and the alternative with the OR is evaluated separately. And therefore, this overall condition, where you combine these three conditions together, would only yield true if part 1 or part 2 yields true. So if isAdmin is true, the code would always run, no matter which age or name you have. If isAdmin is false, then you would only run the code if the name is Max and the age is 30, for example. So if then both A and B are true, then you wouldn't care about C. If C is true, you don't really care about A and B. That's how this concrete example here would work. Now, sometimes you also want to combine conditions differently. You don't want to have A and B combined. Instead, you maybe want to say, if condition A is true and either B or C is true, which is not how this currently would be evaluated, but if you would want to say this, then you can always use parentheses around your conditions to control that. So let's have a look at that. For that, back in our calculator, let's say here, we do check for add, subtract, multiply, and divide, right? Now the problem is, if calculate result should be called with any other value, which of course it isn't here in our code, but let's say we're sharing this code with a colleague, and this colleague tries to run this with just a value of div instead of divide, because he thinks that's all that works, then our code currently would break, right? If I call this with div here, and I have, let's say, 5, and then I want to divide this by 2, then you see the result isn't updated, and here, indeed, I get an invalid output. Now, this is the case because div is not a case handled here. Now, maybe we don't want to change the logic, how we handle that here, but we want to make sure that we don't try to create an output or write to a log if we meet none of these values. So then we could add another if statement here, which executes totally standalone, detached from the other if statements, so they don't work together magically or anything like that. But here we could check if calculation type is not equal to add, and now the double ampersand operator, calculation type also is not equal to subtract, and calculation type, and now I'm running out of space. So what we can do is we can auto format, and this automatically splits this across multiple times. You can absolutely do that. You can write all these conditions combined in one line, or you split them in multiple lines. You don't have to split after the ampersand operator. That's just a recommendation. This code would also be valid, but it's harder to read. So therefore, this is what my auto formatting tool gives me. It auto formats like this. You can generally format in whichever way you want, but this also is a syntax, a coding style, which you will find in many other resources. So it's the one I will use. So now here, I also add another condition. If calculation type is not equal to multiply, and last but not least, if calculation type also is not equal to divide, then we know we have none of the values we're checking up here. So then we maybe don't want to execute this code, and therefore here what we can do in this block is we can return. Remember, if you call return, if you use the return keyword in a function, that means that this function returns a value. Doesn't really matter to us here. We don't expect a value, we don't store it, we don't do anything with it. But it also means that code after the return statement is not executed. And this is indeed a common pattern, that you check some condition, and if it's not met, you know, running this function, running the rest of this function doesn't make sense because it won't work with the values you're giving me, and therefore you might want to return. Hence, we could also grab this if statement and put it right to the top of this. This means that if calculation type is not one of the values we support down there, there is no sense in continuing with this function, so we return right away, and therefore the other code won't even execute. If, on the other hand, you have a calculation type that is add or subtract or multiply or divide, then you would continue, because this total condition here only yields true if every sub-condition yields true, because we combine them with an AND. So this means only if it is not add, and not subtract, and not multiply, and not divide, only then we return. If it is subtract, well then this here is returning false because we're checking for it not being equal. So this would return false if it is subtract, if calculation type is subtract. And therefore this whole condition would return false, and therefore this code wouldn't run, and we would continue with the next lines. So this is how that works and how we can combine conditions. In this case, with the AND operator. But of course, in other cases, you might be interested in the OR operator because you also have multiple conditions where one of them should be met. Actually, we could rewrite this with the OR operator by checking for equality. We could say if calculation type is equal to add, so now I'm not checking for inequality but for equality, or calculation type is equal to subtract, or, and now again I'll structure this across multiple lines here to make it a bit easier to read. And now here I'll check if calculation type is equal to multiply, or if calculation type is equal to divide. So now if any of these is true, this entire condition will return true. So if the calculation type is multiply, this will return true. The others will return false, but this returns true, and therefore this whole condition will return true. Because with OR, the whole condition returns true if one of the subconditions returns true. With AND, the whole condition only returns true if all subconditions return true. Here, one of them suffices. So here we make it into the if block if at least one of them is true, and therefore now we could take all that code here and remove it from there and instead move it into this if block, and therefore this code would only execute if one of these conditions is met. This means we can now remove this check, comment it out for example, because now we're checking for the opposite. Now typically you would want to use this approach here, however, because now we have a lot of code nested into the if block, which can make it a bit harder to read and understand. So therefore checking this instead of having this if statement here makes more sense, but technically you could use both. And this also shows you how you can use AND or the OR operator. And it's of course needless to say that you can also combine them in one condition if you have AND and OR in one condition. So now with that, if I show this to you, with that added, you see that now if I try to divide by 2, we get nothing down there. It doesn't change because this entire function doesn't even execute, because we return here if we pass in a calculation type that's not one of these 4 values. And in this case, I do pass in div here, which is not one of the 4 values, hence we don't continue. If I change this back to divide here, you will of course see that now if we reload here, and now we divide, this works again. So this is how you can use the AND and OR operators to combine conditions. So by now we actually had a look at a lot of different operators which we need in different situations in our code. Arithmetic operators for calculations with numbers, or in the case of the plus operator also with strings. And also the assignment operator and these shorthands for incrementing or decrementing numbers, or for quickly assigning the result of a calculation with the plus or minus and so on operator. So these are things we had a look at. And in addition, we also had a look at these Boolean or logical operators, which we use to derive true or false. So roughly you can say where these arithmetic operators, plus, minus, the asterisk, the multiplication operator and so on, where those operators helped us with numbers, and in the case of the plus also with strings, which we could concatenate, these logical operators produce true or false, which we then in turn typically use in conditions. Now with that we have a solid list of operators. But then we also have these AND and OR operators, and these actually also are operators. Now as you already see, not all operators produce the same result. Some operators produce Boolean values, true or false. Other operators produce numbers or strings. Now, there's more where we dive into, but one thing that already is important to understand is the concept of operator precedence. And for that, attached you find a link to this webpage on MDN which talks about operator precedence. In the end, this is a fancy term for saying how are operators handled, so in which order are they executed, if you will. And the good thing is, when we talk about plus and minus and times and the division operator, the normal mathematical rules apply. So for example, if you have something like 3 plus 2 times 5, the 2 times 5 is evaluated and executed first, and then 3 is added to the result of that. So normal math. And you can override that, just as you do it in math, by using brackets, parentheses. There you can change how that is parsed. And that is all built into JavaScript, and it works just as you would expect it to be. But of course, with the AND and the OR operator, the question also is, which operator takes precedence there? And this article has a table, if you scroll down a bit, which lists the precedence of operators. And you can simply read that table from top to bottom, with the topmost operator taking the highest precedence, and therefore, unsurprisingly, that would be the parentheses. With parentheses, you can basically override the normal rules, just as we did it with the mathematical equation I showed you a second ago. Now, in this table, you'll find many operators which we haven't seen yet. Now, of course, needless to say that I'll dive into all the important operators throughout the course, but you will already recognize some of them. For example, if you scroll down further, you find typeof, you find the exponentiation operator, multiplication, division, remainder, addition, subtraction, and there you can see that multiplication and division have a higher precedence than addition and subtraction, which is just what we saw in that equation I showed you a second ago. And if we scroll down further, we see that the Boolean operators have a lower precedence. The impact of that is that if you, for example, check if 3 plus 2 is smaller than 9 minus 2, then you will actually get true, because JavaScript will first evaluate this, and then compare the results. Because the addition and subtraction operators, which I'm using here, have a higher precedence than these comparison operators. Therefore, these calculations are executed first before the comparison is made. Again, that is basically what our common sense would tell us, and it's good that JavaScript behaves the way. It would be strange if the result of this would actually be, is 2 smaller than 9, and then we have 3 plus true minus 2? That doesn't even make sense, right? So we would expect that this is evaluated, and this is evaluated, and then the results are compared, and thankfully that's exactly what's happening in JavaScript. But of course, the question, for example, is if you have 5 equal 5, and you also want to check if 3 is smaller than 6, or if 10 is bigger than 20, well, in which order is that executed? Does JavaScript check this and then check the result of this comparison? Or does it check, is this true, and this true, or this true? That, of course, matters, because if we change this a little bit and we say, is 10 greater than 5, so this is true, but here we check if 3 is greater than 6, then the result of this first comparison, if this would be executed first, would be false, because yes, this is true, but this here, this comparison is false. So with the AND operator, where both has to be true to return true, this would actually return false. Now, as you can already see here in my IDE, we will get true as a result. So this already indicates that this is evaluated first, and then this. And if either one of these two blocks returns true, the overall condition will return true. And that's in case what's happening here. Instead, if it would be the case that this is evaluated, and then this would have to be true, then it would also work like this, but not, for example, if we check if that is not equal. Then, if we say this has to be true and this has to be true, we would have a problem because this first part wouldn't be true. So what I'm saying here basically is that AND has a higher precedence than OR, and indeed that is what we see here in the table. The logical AND has a higher precedence than OR, which means that first JavaScript connects these two pieces and evaluates them, and then this operator kicks in and considers the second condition as well, which means that if this is true, we override the fact that this yields false. So you can always check this table if you're not sure about some order, but actually in most cases, as I mentioned, it's just what you would expect to happen. So definitely don't learn this by heart. There also are operators in here which are quite niche, range, which you will never use, to be honest. So don't learn this by heart, just take it as a reference if some behavior is unclear to you. In general, common sense is what's happening in JavaScript or what's getting applied there. And the one thing where you might not have an intuition is maybe that and or thing. Well, there and takes precedence over or, which means first this is evaluated and then it's compared to this. And there the or operator simply means if one of the two is true, the overall statement returns true, the overall expression returns true, and therefore this overall returns true because this is true, and therefore thanks to the or operator, this doesn't matter, the fact that this is false, but still important to know this was grouped together because and takes higher precedence. So instead of grouping together this was grouped together. Now in JavaScript, you also have a concept which is called falsy and truthy values. Now we learned about false and true, which were these Boolean values. Now what's falsy and truthy? Is this like kind of a strange special extra data type? No, it's actually just how JavaScript under the hood evaluates conditions. Generally, JavaScript conditions work with Booleans, true or false, but they also work with these falsy or truthy values. Here's an example. Let's say you have a constant name input which holds a value of max. Here it's hard-coded into the code, but of course that could be fetched from an input field on the web page, let's say. And then we use this in a condition here where I compare the value in name input to the hard-coded value of max. Well, we know that name input stores max, and therefore this of course would work. To be precise, this condition yields true in this example here, so it yields a Boolean value, and therefore this of course works. That's what we saw thus far. Now consider this code snippet here. We again have name input which holds max, in this case hard-coded, but could be fetched from the input field on a web page. But now in the if condition, I don't compare name input to any concrete value, I just have if name input here. And this name input constant here, of course, holds a string, not a Boolean, right? We initialize it one line above it, so this holds a string, not a Boolean. And still this works. And this works because JavaScript tries to coerce values to a Boolean value if a Boolean is required, as it is the case in the if statement. So yes, if statements work with Booleans, but JavaScript tries to convert a value to a Boolean if it doesn't get a Boolean comparison and also not a Boolean itself. So for example, if you have a variable which you pass into an if condition, which you don't compare to anything, but you just say if that variable, and that variable holds a value of 0, then this will actually be treated as false. So 0 is treated as false in a condition. Any other number, including negative numbers on the other hand, are treated as true. So 0 is kind of a special case which JavaScript treats as false. Now when might this come in handy? Let's say you're doing some division and you don't want to divide by 0. Now let's say the value is provided by the user enters a value in the input, and you want to make sure that you don't divide by 0. Of course you could check if user input is equal to 0, and if it is, you return, or you just use the shortcut of just plugging in the variable name. And actually again, our calculator is a great example. It actually never makes sense in our calculator if the user enters 0 here. Adding 0, subtracting 0, or multiplying or dividing by 0 doesn't really make sense. You could say multiplying resets it, but let's say we don't want to have that case. And dividing would even be illegal. It's not allowed to divide by 0. So what we could do in the calculator here, in the calculate result function, besides checking our cases here, we could also make sure that we return if, and now we can actually use the OR operator here, if the entered number, and for that we just have to extract it before we run that code here. So if the entered number here is equal to 0. Of course we could do that. What this would now do is, it means we would return right away if either the calculation type is not add, not subtract, not multiply, and not divide, or if the entered number is 0. So let's test this. If we reload this page, of course, everything works here. But if I enter a 0 here, you see our output doesn't change down there. So that works. Now, again, we can do that, but we can also say if entered number, or to be precise, since this would be treated as true if it's anything but 0, we can add an exclamation mark in front of this. Now this might look strange at first, but what this says is if not entered number. You might remember that slide at the very bottom here, the exclamation mark operator, that's what we're using here. This negates a value and checks if it's not true. So in this case, entered number, if it's 0, is treated as false by JavaScript. It's falsy, and therefore by adding an exclamation mark in front of it, we kind of invert that value. We say if that's not the case, then we want to make it in here. Now, since 0, if the user entered 0, is treated as false, this means if not false, which is true, then execute this code. So if entered number is a falsy value, then not falsy will return true. And if we return true here, well, then we make it into this if block, and therefore we return from this function. We don't execute the function. If entered number is any other number but 0, including negative numbers, then it's truthy, and then with the exclamation mark in front of it, it's converted to false. So if false, we'll never execute the code in there, right? Because this code only executes if this first condition is true. And therefore, we don't make it in here, and we don't skip function execution by returning early. This is how this works, and this is the idea behind the truthy and falsy values. You don't always have to make an explicit comparison with the equal or greater than operators. You can also just throw in the variable or the value which you're interested in, and then just take this as a condition itself. And if it doesn't hold true or false, JavaScript tries to convert it to true or false. And there, 0 is treated as false, any other number is treated as true. Now for strings, an empty string is treated as false, any other string is treated as true. And for objects and arrays, it's important to understand that all objects and arrays, even empty ones, are always treated as true. So an empty object is not treated as false, it's always treated as true, no matter if there's data in it or not. Null, undefined, and not a number, by the way, are always treated as false. So these are the truthy and falsy values you can keep in mind. You can take that slide, it's attached, and kind of print it out and put it next to your desk. These are the special cases in JavaScript. If you just throw in a single value or just a variable with a value in it into an if condition without a comparison operator, so without the equal sign or the greater than operator, so just the variable like this, then JavaScript will look into the variable or look into the value, and if it's not true or false already, it will try to convert it to true or false, and this is how it then does it. Now that's it for our calculator and for the basics about if statements. Before we advance to loops, I'd say it's definitely time to work more with if statements to get a better feeling for them, for the comparison operators, for booleans, and for all these things which we used a bit here, but which is still brand new and therefore definitely needs more practice so that you feel confident using if statements in your code. Now, to practice all that if statement stuff and the related concepts a bit better, let's work on a new little application, a new little project, a little website here. As before, fully driven by browser-side JavaScript so that we can experiment with the things we learned and get a nice visual output for that. Now, this is the website I loaded. You find it attached, of course. Again, it's made up of an index.html file and of an assets folder. The assets folder holds a scripts folder with an empty app.js file and a vendor.js file, which is kind of a black box to us right now. It basically establishes a communication channel, you could say, between our HTML code and JavaScript so that we can manipulate the document we see there, something we will, of course, learn in great detail later in the course. We're just not entirely there yet. So for now, we just treat this as a black box that yields us some global variables we can use to listen to button clicks and so on. The app.js file is where we will write our code, and of course we also got some styles here in the app.css file. Side note, all these styles are optimized for Chrome because I recommend following along with Chrome here, not because JavaScript wouldn't work in other browsers, but simply, especially for the styles now, so that we all always have the same thing on the screen. Now, this is what we do have on the screen, and what we're building is a little monster killer application. We got the health of a monster and we got the health of a player. We also got a bonus life. In case our health drops to 0, we'll be able to recover 1 time only. We got 4 buttons which we can press to attack the monster, to launch a strong attack against the monster, to heal ourselves, and also to output some log information about the past rounds. Now, that's what we'll work on. Right now, nothing works because all the logic is, of course, something we will need to write. And maybe you can already see some of the if checks we probably will perform. Maybe some related to the buttons, whether we launch a normal or a strong attack. But also definitely we'll need to check after each round whether we won or not. So whether the health of the monster and or the player is below 0 and we therefore need to quit the game or stop the game. So that will be some if checks. And actually there will be a couple of other if checks as well, because we'll also add a functionality where when we load this page, we actually asked the player how much health monster and player should have. 100 health points, 50, 1000. And we'll need to check whether the value the user entered is a valid value, and so on. So there will be a couple of places where we need if checks, and therefore a couple of places where we can practice the things we learned. So let's dive right in. Now, how do we dive right in? I would suggest let's start by making sure that this attack button does something, that we actually shrink these health bars. Now, as I mentioned, we need to configure how much health is available, and later we'll ask the user of this web page for a starting value. For now, we will hard code it. So here in app.js, I will start by adding a constant, which I'll name chosen max life. Again, later the user will be able to choose that, hence that variable name. Right now, I will hard code it, and I will set it to 100 health points. Now, in addition, I'll also set an attack value here. Now, this also is a constant because this will not change throughout the program lifecycle. By the way, the health, of course, will change. So this actually should be a variable with let. My mistake. So this should be a variable. The constant here, however, will not change. And the order, by the way, does not matter. You could have the variable first, whatever you want. But I like to have my constants that never change first. And the constant here which won't change is the attack value, which I'll set to 10. And of course, here you can experiment with different values. This is basically how hard we hit the monster, though I will say in the vendor.js file, we got a little randomization logic built in so that the attack value I set up here will actually be treated as a maximum value, and we will generate a random value between 0 and that value to have a little bit of randomness in the game. Now, also one little thing which I want to change here. Attack value is a constant which will never change throughout the entire program. Therefore, it's a constant, as I just said. We can also leave it like this, but for such a global game value, which we really hard code in there, so which we don't derive from, let's say, some user input, which thereafter never changes, but which we as a developer set up as a global value which you just hard code into your code, it's also quite common to use all uppercase characters there and separate words with an underscore to make it really clear that this is a global value which you just hard coded into the code as we did it here. It's not required. Technically, it doesn't make any difference. It's just a convention you see in some programs, and therefore one which I want to establish here. Again, not a must use, but an option. So that's the attack value, the maximum attack value we can get as a player. That's the max life for both the player and the monster. And the first thing we can do, therefore, is we can call a function which is exposed by vendor.js, the adjust health bars function, which takes the maximum life and which then just sets the maximum life in our user interface, so in the HTML code in the end for these progress bars. So here we can call adjust health bars and simply forward the chosen max life so that this gets updated on the screen whenever we load this game. Of course, we see no difference here. The bars were full before that, but if you inspect them actually with right-click inspect here in Chrome, you see the HTML code as it's configured for this running web page, and there you see the max value is set to 100. The current value is also set to 100, and if you would change the chosen max life here to 50, and reload, you would see that these values also change to 50. So that's the impact we're having here, just so that you see how this all is connected. Okay, so with that, we got the chosen max life set up. We're setting this in our web page, so to say. Now we want to connect this attack button here to a function which we execute, which then lowers this health. So for that, in the vendor.js file, we expose this attack button. That's a constant which we can use. By the way, these constants are not written in all caps because these don't hold hard-coded string or number values, but instead references to parts of our HTML code, so parts of our web page. And there, this is not such a global hard-coded value, but it's a bit more dynamic, even though it, of course, also won't change whilst the app is running. So we can refer to the attack button constant here, which is basically a reference to this button. And we can use this here to then also add an event listener here. And this event listener should listen to the click event and then fire a function, which I'll add here, which I'll name attack handler. And now the name of the function is totally up to you. Previously in the course, I used a different naming scheme. Now, from now on, I will use a different one where the functions which I assign to event handlers will always be named some description of what the function is there for, and then handler at the end. This is absolutely not a must do. It's also not the only convention you will find out there. Some people also use a convention where these event handler functions start with on, and then, for example, on click or on attack. Or you just name it attack monster if you want to go with that, just to make clear which functions are attached to an event listener and which functions aren't. I will go with that attack handler or with that handler convention here, but again, that is optional. So attack handler is the function I'll point at here on my event listener, and in this function I now want to launch an attack towards that monster. Now, to launch that attack, we can have a look at the vendor.js file, and there we actually have that deal monster damage function. What this does is it calculates a random amount of damage based on the damage we feed in as a parameter. Then it adjusts the monster health bar, so the health bar we see on the page here, and it returns the damage it calculated, so that we can also use it in the app.js file. So I want to call deal monster damage here, and I want to pass in my attack value here. And this will return the damage that was dealt, which I'll store in a damage constant, a constant because this value will not change for this function execution. So I will store it in this local constant, which is available inside of this function thereafter. And now we can use that stored damage to adjust our monster health. Now for that, up here, I'll add a new variable, monster health, or current monster health, which I'll set equal to chosen max life, which of course renders this variable a bit redundant. It will become more important later once we let the user set this. For now, it's just like a dummy data container. We could of course also initialize current monster health to 100 here. But again, since later this variable will be populated by the user, I'll use that extra variable. And the current player health can also be initialized to the chosen max life. Now that current monster health should be reduced by the damage which was dealt down there. And for this, of course, we can use the minus equal operator and set this to damage. This means that current monster health is set equal to current monster health minus damage. Now, the UI is updated by the deal monster damage function, as I explained. And with that, we should be able to attack the monster with a normal attack. If I save this and I reload, and I click attack, you see the monster health bar shrinks by different amounts because it's random, but it shrinks. Of course, we have no win condition though. So it would make sense to add this, and therefore, of course, we'll need an if statement. So it's time for our first if statement. We want to find out if after an attack, we won. So here in the attack handler, we could add an if statement with the if keyword and check if the current monster health, after we deducted the damage from it, of course, if that is smaller or equal to 0. because I also want to check for equality, because the monster is dead not only if its health is below 0, but also if it's equal to 0. If that is the case, then we know that we won. So in this case, we could throw an alert where we say, you won. So this code here will only execute if this condition here is met, and this condition is only met if the current monster health is below 0 or equal to 0. So with that, if we now reload this and we launch a couple of attacks against the monster, spam this button until the health bar is below 0, we get this 1. Now please note this message is output before the health bar updates, simply due to the way JavaScript works here. It blocks the UI update until we dismiss this dialog here, but the general logic works, and if we dismiss it, we also see the health go down. So this works, and this is our first basic if check in action. Now of course, it's a bit boring if we can attack the monster, but the monster is not able to fight back. So what we actually want here is to adjust the logic to let the monster fight back. To do that, after we hit the monster should immediately lash back at us. So it should automatically hit us after we hit it. Now for that, in Vendor.js, we got the deal player damage function. It works basically like the deal monster damage function. It takes some damage, then calculates a random damage which is actually dealt, adjusts the player health bar in the UI, and returns the dealt damage. So in app.js, I can take advantage of this. For that, we just need to define what's the maximum damage of the monster. And here I'll add a constant monster attack value, again hard-coded into here, and I will let the monster hit me back with, let's say, a maximum damage of 14. So more than we can hit it for, which means that right now we will need a lot of luck in order to win, because these are maximum damages and the monster has an edge there. Of course, the game will evolve throughout this module and will also make the other buttons work, which will give us an edge again. So let's take that monster attack value here to let the monster deal some damage to us. And for this, I will get my monster damage, let's say, or player damage, depending on how you see it. It's the damage dealt to the players, so maybe player damage makes more sense. And for that, I will call deal player damage here, forward the monster attack value, and then reduce the current player health by that amount, again by simply deducting player damage with the minus equal operator. Now here, we want to check if the player won, so if the current monster health is smaller or equal than 0, or if the monster won. Now you might think that we simply add an else block, right? Because if we haven't won, if the monster health is not below 0, then we lost. But that would actually be wrong. Keep in mind that the attack handler is executed for every click on the button. So we run this check here for every button click. And on most clicks, especially when the game just started, neither party won. So we don't want to let the player lose in the else case, because if we do that, if we say you lost here, you will see that if we reload here, right after the first attack, we get the you lost message. Which makes sense because we run this check on every button click. Now, after the first attack, we certainly didn't win, so this condition is not met. Hence, we make it into the else block and we lost. So else is not right for this scenario. Instead, I want to check else if. So if we haven't won, if maybe the monster won. So here I'll check if the current player health is smaller or equal than 0. Now, of course, you could argue about this logic, because what I do at the moment is I let the player hit the monster, and then the monster immediately hits back, and only thereafter I check if the player won, which means the monster already dealt damage to us, and still, even if that damage took us below 0, we will have won if we also took the monster below 0, if we also reduced the monster's health below 0. Which means the monster's damage basically is irrelevant if we also took the monster's health below 0. And of course you could argue about that. Maybe you instead want to check if the player won here after the player dealt damage, and therefore don't give the monster a chance of dealing damage to us if we won. Or you just don't care, you always execute both, and then you give the player the advantage of checking the monster health first, and therefore the player wins, even if the player's health also is below 0, because the monster's health is below 0 after this attack. So a lot of talking about how you look at this. From a technical perspective, it's way easier. We check if this condition is met, so if the monster health is below 0. If that is the case, we won. If that's not the case, we check if maybe the monster won, so if the current player's health is below 0. And if neither of the two is the case, then nothing happens in this if statement. Neither of these two code lines is executed, so neither the you won alert nor the you lost alert is shown, and instead we just finish the function execution and we're done. And that will be the case for most clicks, for most executions, especially at the start of the game. So with that, if we now save this and we reload, let's attack, and you see the monster is hitting us real hard here. We had a couple of weak hits, and therefore we're probably going to lose. So let's see what the end result is. And yeah, we get the you lost message here once our health dropped below 0. So the else if check is also working here. Now, to fine-tune this a bit more, we could of course say, yeah, we really want to tweak this, and we shouldn't be able to win if our health is also below 0. Instead, it should be a draw if both health values are below 0. So here we could say, we won if the monster health is smaller or equal than 0, and, now with the AND operator, the current player health actually is above 0, so greater than 0. Not greater or equal, because if it's equal we lost, but greater. So we can only win if the player's health, still is above 0. And the same for the monster. The monster only wins if the player's health, is below 0, and the monster health, on the other hand, is above 0. And that of course means that if both health values are below 0, it's a draw. So we could add else alert, you have a draw. But of course that again would be wrong, because if we do that, keep in mind attack handler executes for every click. So this else case will basically execute whenever neither of the two conditions is met, and that most of the time will be the case. So now again we have the same case as before. On the first click we get that you have a draw message. Because else, again, for this scenario, not always, but for this scenario is wrong. Instead here I want to check else if the current player health is smaller than 0, smaller or equal than 0, and the current monster health also is smaller or equal than 0. Only in that case we have a draw. Now to simulate that, let's start with a max life of 5, where we have a realistic chance, or a more realistic chance, of actually launching an attack that takes us both below 0. And let's have a look at this. If I now click attack, yeah, right away I have a draw. You might have to test this a bit more often, because since the damage is calculated randomly, you can certainly have situations where you hit the monster for 2 and the monster hits you for 6 and therefore you lose. But after clicking this a couple of times, you should get that you have a draw message here. So with that, let me take it back to 100. With that, we now have logic that works correctly. Let's also check for a regular win or loss. Yeah, we lost here. And with that, we got our basic if statement with if, else if, and different logical operators, as well as the AND operator to also combine multiple conditions. So already quite a lot of the things you learned about in the past lectures are getting applied in this first crucial element of our game. So now that we got our basic attack handler, let's also make sure we can do a strong attack. We can perform a strong attack here by clicking the strong attack button. Now for that, in the vendor.js file, we find that strong attack button constant, which in the end gives us access to that strong attack button in our HTML code. And therefore, of course, in app.js, we can add an event listener, where we again listen to a click event on that button, but now I want to execute a different handler, a different function, of course, a function which deals more damage to the monster. So for that, I'll add a brand new function here. The strong attack handler sounds like a sensible name. And let's connect that to the event listener, just as we connected the attack handler. And in there, I generate generally, of course, want to do the same as I do here. So I will copy it over, though, as you already know by that point already, when you copy code, you most of the time can avoid it and write more elegant code instead. So I will copy it for now, but this will not be the final code. Instead, especially with if statements, we can write this in a more reusable way. Nonetheless, let's start like this, strong attack handler. Let's go up there and define a strong attack value so that we have some value which we can change in one central place, up here in this constant, which is our maximum strong damage that is dealt. And maybe let's go for 17 here. Again, you can play around with these values. So the strong attack value is now, of course, what I use in the strong attack handler here when we deal damage to the monster. The damage the monster deals to us stays the same, so the monster only has 1 damage it can deal to us, 1 maximum damage. And the win condition check here, of course, also stays the same. So now with that should already be all. If we now reload, we can press strong attack, and as you see, the monster health declines, but player health a bit more. It's really close. Yeah, we might be winning. We won. So a close finish, we won, and that works. And right now, of course, we don't reset the game thereafter, so we can continue clicking these buttons, which is kind of redundant. We'll take care about this later. And we're also not taking care about our bonus life in case we're losing. That's also something we'll take care about later. For now, let's focus on the strong attack handler, which does its job, but as I mentioned, lots of code duplication here, which is never a good sign. So how could we minimize that? How could we reuse some code? For that, let's simply analyze which code is equal. And, well, that's a quick analysis. All the code is equal. The only thing that really differs is the maximum damage value we're passing to deal monster damage. So that's really a redundant extra function we have here. Well, to reduce the code duplication, let's add a brand new function, which we maybe just name attack monster, because that's what we'll do. I don't add handler at the end, because this will not be attached directly to an event handler. Instead, attack monster should be a function which I want to call directly from inside attack handler and from inside strong attack handler. And I want to pass a parameter to this attack monster function that identifies the attack mode, if you want to call it like this. So of course you can give this parameter any name you want. I just go with mode here, but the name is totally up to you. And in here we can then check the mode in the if condition. And let's say the mode is a string. You could alternatively also go with numbers and say 0 is the normal attack, 1 is the strong attack. Here, since it's easier to read, I'll go with the string value and check if mode is equal to attack. If that's the case, then I want to do my normal attack and calculate the value based on that. Otherwise, I will go with the strong attack. So in the end, what I want to do here is I want to create a variable which I'll name max damage, which initially is empty. And if the mode is attack, I'll set max damage equal to attack value. Otherwise, I'll set max damage equal to strong attack value. And of course, here I can use else because I will call attack monster from these two functions. And I either pass in mode, which is a string of attack, or I pass in no mode or some other string, and then this will automatically treat this as a strong attack. You could, of course, just as before with the calculator and the division, also be more specific and check if mode is equal to strong attack, and simply do nothing if the mode is neither of the two values. So either of the two code snippets or approaches will work, just what they do if you pass an invalid mode is different. You can either always perform a strong attack, or as with this case here, only perform a strong attack if the mode is really set to strong attack. Now, why am I doing this? Why do I create that max damage variable, which is then set to different values here? Because now we can actually grab this entire code here from attack handler and move it below this if statement, and now simply pass max damage here to deal monster damage, because now the max damage is dynamic, and it's dynamically set here based on the mode we receive as a parameter here in attack monster. And all the other code is always the same, which makes sense, I guess. So now we just have to call attack monster from inside the attack handler. And since this is the function that's executed when we click the normal attack button, here, as a value for mode, I want to, in the end, set my max damage to the attack value. I'll therefore pass a mode of attack in there. So I simply forward attack here. And now we can call the same function from inside the strong attack handler and forward strong attack. Pass in strong attack as a value for mode. Now, in case you're wondering why we're not directly setting attack monster here on the event listeners, we could almost do that, but keep in mind that here we can't specify the value for the parameters we're passing in. So this mode parameter, which we expect here, when we attach a function to an event listener, we can't specify this. Actually, we can, but we haven't learned it yet. So for now, let's take this extra step of doing it in our handler functions. Now the handler functions are very lean. They execute the same function with different data which is passed in, and in that function we then take that different data, use it in an if statement, and therefore change the one piece of logic that does differ for both buttons. So now if we save that and we reload, I can launch normal attacks or strong attacks against the monster, and both works as before. Now here we have a draw actually. Good to see that. And we do this in an elegant way by reusing code with the help of an if statement. So we can attack the monster. What about healing? The heal button doesn't do anything. And therefore it would make sense that we also react to clicks on that. It's the heal button constant here. So we want to add an event listener to that. And of course, we want to trigger a function when this button is clicked. So for that, we can register a new function, add it here maybe, the heal player handler or whatever you want to name it. And this heal player handler function should be triggered when the heal button is pressed. Now what happens in that heal player handler? In the end here, I want to heal the player by a certain amount, and that amount should also be set up there so that we can conveniently change it in one single place for the entire game. I will name it heal value and maybe set that to, let's say, 20, which is a lot, and you can definitely play around with different values here if you want to. Now in vendor.js, we will also have the increase player health function, which is in the end the heal part. This does not randomly calculate a value, so instead the heal value we have will always be the real heal value applied. So there is no randomness involved here. This will just update the player health bar in the UI. So now with the heal value set up there, we can use it in the heal player handler. And there, I in the end want to call increase player health, which is that function I just showed in vendor.js, and forward the heal value so that we can heal the player. And thereafter, of course, still the monster should be able to hit us. So in the end, we will heal, but we will also take an immediate hit by the monster. So the monster hits us after every turn, no matter if we attacked it or if we healed ourselves. So we want to let the monster attack us. So that means that this code here also needs to run. And of course, since the monster will hit us, we could, even though we healed ourselves, we could theoretically be dead. Not really, with a heal value of 20 and a max monster attack of 14. So in this scenario, we actually can't be dead. But if the monster would hit us for a value of bigger than 20, so a maximum damage of bigger than 20, or if we would heal for less, then we could be dead. And since these values can be adjusted by you as a developer, I want to handle that case as well. So we could be dead, hence I also want to have my win condition be executed here. Certainly the player can't have won because the player dealt no damage to the monster, but the monster might have won if values were different. So in the end, running this entire code again doesn't sound too bad. Now obviously we can copy it over, but you know what you learned about copying code, not the best idea. So instead, let's add a brand new function, which we maybe name and round. And in there, I have my code where the monster hits us and where we check whether we won or the monster won, or if we have a draw, or if nothing happened. Now this AND round function can now be executed whenever we had this code before. So in the attack monster function, after we dealt damage to the monster, we can call AND round like this, and now this will, well, AND round, let the monster attack us and check the win condition, and we do the same here after healing, call AND round. Again, code reused efficiently, very lean functions defined up there, and a reusable AND round function, which we can call whenever a round is over. So even if we would add more options here. With that, if we now hit the monster and we heal ourselves, you see the health goes up a bit. Here we go, and so on. But we can never heal to full because we always get damaged by the monster, or at least it's very hard. One problem we have with this heal logic right now, though, is that we can actually also heal if we already have full health. So if I click heal here, we actually take damage because the monster still hits us, but with enough luck, we can actually go above our maximum health. By the way, you will also see that if you press heal a lot, you eventually lose, which is very strange. Now that's also something we'll have to fix. Now the reason for us losing is that whilst our progress bar is updated by calling this function, our health, which we manage here, the current player health, which is important for our win condition, actually isn't adjusted. We adjust it when the monster hits us, then we reduce our health. Here, current player health reduced. We also reduce the monster health when we hit it, but we don't update, we don't increase the current player health if we heal ourselves. So that's one thing we have to do. We have to set the current player health plus equal to heal value here. Otherwise, the progress bar health does not reflect our internal game health. And in addition, I want to make sure that we can't heal for more than our maximum health, so that we can't go above our maximum health. To guarantee that, we can actually add a new variable here in the heal player handler, maybe named heal value, like this, which of course is different from our constant here. It's written in a totally different way, and JavaScript is case sensitive. And of course, there also we have an underscore, which we don't have here, so it's a totally different variable. Even if it would be the same, thanks to variable shadowing, we could have the same name here in a function as we have globally, by the way, but this is a brand new variable, doesn't even have a shared name anywhere. And I'm adding this variable because now again, we can add an if check here and check if the current player health is greater or equal than the chosen max life, which is hard-coded to 100 here, which later can be set by the user. So the chosen max life minus the heal value. Now what does this comparison do? Now keep in mind that thanks to operator precedence, this is evaluated first. So this basically at the beginning of the game, for example, calculates 100 minus 20, so 80 as a result. And therefore we check if the current player health is greater than 80 here, which at the beginning is the case, because at the beginning the current player health is equal to the chosen max life, which is 100. 100 is greater than 80. If that's the case, then we know that the heal value is either just enough to fully heal us back up to our max health, or to even heal us beyond that. Put in other words, if we just applied heal value to improve our health, we would at least go up to our initial health, maybe even go higher than that. So in that case, what I want to do, I want to maybe throw an alert where I say you can't, and now I want to use a single quote here, even though my entire string is surrounded by single quotes. To fix that, we can use double quotes to surround the string. Then I can say you can't heal to more than your max initial health or something like that. And thereafter I set the heal value equal to the chosen max life minus the current player health, which basically means we heal the player back up to its initial health, but not above that. Now, else, which is the case if our current health is not greater than this difference. So for example, if our current health is 60, this difference here for the current initial values always is 80. Then if we have a current health of 60, we don't make it into this block, then we go into the else block, because now we know if we apply the full heal value of 20, we will certainly still be below our maximum. So we don't need to tell the user that we healed him for less. Instead, we can apply the full heal value, so the full 20 health points in this case here, to heal the player. So then I will set heal value equal to our global heal value constant here. So here we apply the full 20 health points in this case. Here we might also apply the full 20 health points if the current player health is exactly 80. But for example, if it's 90, this here will only be a value of 10, because we can't heal the player for more than up to his maximum initial life. So why did I do all of that? Because now heal value is a dynamic value which takes the maximum amount of life and the current amount of life of the player into account. And therefore now we increase the player health by this heal value and also our in-game player health by this value. And now if I save that and I reload and I click heal right at the start, we get this alert. And we are healed back up, but since the monster immediately hits us, we actually don't see that. So healing at the beginning of the game just is stupid, as you can see. But if we then attack, for example, here I get a warning. Still a warning, but here we see the effect a bit because the monster didn't hit us as hard, and so on. So this now works, and if I'm a bit lower on health, we don't get the warning, of course. We only get this if we're high on health, and we would potentially heal ourselves up for more than our max health before the monster then hits us again. So this is the healing functionality. Now we also don't lose because of some out of sync in-game health and health bar health, and therefore now we successfully added a heal functionality with another if check example, in this case used to ensure that we can't heal for more than up to our maximum initial health. So we can attack the monster normally, we can launch a strong attack, we can heal, we get various checks in there also to see whether we won. One thing we're not doing is we're not resetting the game after we won. We're also not asking the user for an initial max health value. Right now we're hard coding this to be 100. I said that I want to let the user of the game, of this app, of this website, choose that value. And what we're also not doing is we're not utilizing this bonus life. Now let's maybe start with the bonus life. The idea behind the bonus life is that if we're low on health, and we would die, like now, if I click attack and the monster hits us, we would very likely die. Then we actually don't die, but instead we consume this bonus life, and we got, well, time or an opportunity to come back. Okay, so I didn't die, now I should die, I lost. And here, we shouldn't lose, but instead consume the bonus life, freeze our health, so don't reduce our health for this turn, and thereafter we have a chance to heal back up, or if it was close, maybe now launch an attack towards the monster that kills it. And therefore we have one chance to recover throughout the entire game, even if we then restart it later. So this is the idea behind the bonus life. Where should this bonus life come in there for? Well, the end round function makes sense, because this is where we check whether we lost, and here actually, before we check this, we should check whether we have a bonus life. So in here, we can add another if statement and check if the current player health is smaller or equal than 0, which means we would be dead. And now I also want to check if we still have our bonus life. Now for that, since it's exactly 1 which we can consume, I'll add a new variable up there, which I'll name has bonus life. And I give it this strange name because this will actually hold true initially. So this is now a variable that just holds a Boolean value, true or false. Not a truthy or falsy value, but a real Boolean. And Boolean variables are typically named like this, where you kind of indicate what you're trying to control here. So here has bonus life. In other programs, you might have something like is logged in to indicate whether the user is logged in or not, which also makes sense to be true or false. Of course, we don't have that here, but that would be another example. So here bonus life has bonus life is true. And therefore here I can check if we would be dead and we have a bonus life. So if this is true. Now we can't just check this like that. You could say equals true with triple or double equal signs, and that would not be wrong, that would work. But as I also showed you on the falsy truthy slide, if you just reference a variable without a comparison operator, JavaScript will actually try to convert this to true or false and then take this in its condition. And here, of course, this conversion is really easy because there is nothing to convert. This is a real Boolean. It is true, so JavaScript will check if this is true and this is true, which means we would be dead, but we do have a bonus life. And in that case, I'll set the has bonus life variable to false because now we lost our bonus life. And I will call remove bonus life, which is a function provided in vendor.js, which will in the end just update the UI. And now I also want to make sure that our health is now not below 0. So actually here at the beginning of the end round function, I'll log in the user's health before the monster hits him. So initial player life is here set equal to current player health. Maybe also name this health therefore. So initial player health is equal to current player health. Thereafter the monster hits us and the current player health is reduced. But since we stored a copy here in initial player health is not affected by changes in current player health. And therefore here we can set back the current player health to the initial player health. So we reset it to the health before the monster hit us. That's what our bonus life does here. Now let's just also inform the player about his luck and say, you would be dead, but the bonus life saved you. And of course, also make sure we update the UI appropriately by using a function you find in vendor.js, and that's the setPlayerHealth function, which just updates the player health bar. You simply pass it the health to which it should be set. So here, that's of course the initial player health to which we also reset our in-game health. And with that, now let's save it, reload this game, and now attack the monster a couple of times so that we would die. And now we would normally be dead, but the bonus life saved us. And indeed here, we got a little bit of health left. So maybe let's try heal up. And now we won. You also see the bonus life was removed here. So that's the bonus life, again, with some if checks implemented. Here also with a variable which we don't compare to anything, which again, we could do, but it's simply redundant because if you don't add a comparison operator, JavaScript will try to coerce this value to true or false, which here is simple because it is a real Boolean, and therefore we can use it like this in the condition, and hence this works. Now that's the bonus life functionality. What about resetting the game once it's over? For that, I will add a new function here, which I'll name reset, not reset game, because that's actually a function I have here in the vendor.js file to update my health bars there. So I will just name it reset here in the app.js file, because these names are shared globally across scripts, as you learned. And here in the end, I want to basically do the same I did here. So I want to copy that code into reset without let though, because I don't want to reinitialize these variables. Instead, I want to use the global ones and just set them back to the chosen max life here. I will not reset the bonus life. That's not the idea of this game here. I don't have a function in vendor.js to update the UI. So if you would want to add such a functionality, you would have to write such a function on your own. Not the goal here. Bonus life only exists once across all games. I will just reset the health and therefore also call reset game here, which is that function in the vendor.js file which resets the health bars there. Now we can call reset whenever we want to reset, and that of course should be the case whenever we lost, we won, or we had a draw. So whenever the game is over. This means here in end round, in all these cases here, we can call reset, just like this. Now there's nothing wrong with doing it like this, calling reset in 3 places. A bit of code duplication, which you can't really avoid. If you would want to rewrite it, and I would argue that this is not necessarily shorter, but if you would want to rewrite it, you could add a new if check which runs after this one, where you check basically all conditions combined, and then you call reset. So here you would check if current monster health is smaller or equal than 0, and the current player health is greater than 0, in which case the player won. Or, and now we got and or combined. Due to the way operator precedence works, this is executed first, thereafter the part after or, and then both combined with or. So after this, I check this condition here. Let's now split it across multiple lines to make it easier to read. Here, my IDE automatically added parentheses for readability. These are not required. Due to operator precedence, this code will work in exactly the same way, no matter if this is wrapped into parentheses or not, because AND has a higher precedence than OR, which means this is evaluated first, then this, and then the result of both operations are compared with this OR operator. So if this yields true and this yields false, for example, the overall result will be true, because with OR, if one of the two conditions is true, the overall condition is true. Now, of course, we're not done here, though. I checked for the monster health, for the player health. Now we can also add another condition, and that would be this one here. And with that, we have all these conditions up there combined, and we call reset thereafter. Now, actually, we can shorten this, though, and then this becomes a better alternative. I wanted to show this first to practice the combination of AND and OR. In the end, the only thing we care about here is whether the monster or the player health is below 0, right? Because in either way, one of the two lost, or it's a draw. But we don't care whether it's a draw or if we have a winner here. We just care whether some value, some health is below 0, because that means the game is certainly over, no matter who won or if it's a draw, and therefore we want to reset. So we can shorten this a lot, and again, then it becomes a real alternative to calling reset 3 times here. We can shorten this a lot because all we have to do is we have to check if the current monster health is smaller or equal than 0, or if the current player health is smaller or equal than 0. Now we have a very short condition here, and we want to call reset if that's the case, if that yields true, because that means we have a winner or we have a draw. In either case, we want to reset. So now with that, let's save it, let's reload, and let's try. Let's hit this, and we won after clicking OK. This should normally reset, but it didn't. Yeah, because reset game, of course, takes a value here, the value to which it should reset our bars. And that's, of course, the chosen max life, which we need to pass in here in our reset function. And with that, let's give it another try. Let's hit attack here. Looks like the monster is going to win now. Well, we have our bonus life, right? But if I click attack again and again, now we really lost. But thereafter, we reset this. And now maybe with a couple of strong attacks, we should win. And we do. And now let's see if I can get a draw here. But that's actually quite hard, to be honest. Yeah, it's really hard. You might get a draw here. You will see that even there, you will reset this in the end. Yeah, here is a draw. Yeah, so this all works. Now we can reset this. Really nice. And with that, the one thing that's missing here is that we let the player, the user of this website now, not you as a developer, but the user of this website, that the user may decide what the initial health values are. 100, 50, 1000. That is something the player should decide, and that's what we'll implement next. Now, how can we let the player of our game choose that initial max life here? For that, JavaScript has a nice little built-in function. So the browser has a nice little built-in function, I should say. And in JavaScript in the browser, you can therefore use that. And that's the prompt function. It's a bit like alert, which shows a message dialog. This also shows a dialog, but it shows a dialog where the user may enter something. So here, first of all, we have some text which is displayed to the user. For example, maximum life for you and the monster to tell the user what he should enter. And then you also can define an initial value, which should be a string. So for example, 100. Now if you save that and you reload this page, you're presented with this prompt where you can enter a value, for example, 70. Now if you hit OK, nothing happens right now because we're not doing anything with that entered value. The prompt function actually returns the value the user entered. So here I got my entered value constant, which holds that value the user chose here. Now that will be a string, not a number. That's important, but I want to have a number here to do my calculations correctly and not start concatenating strings or anything like that. So I want a number here, and therefore we should convert this to a number. Of course, you learned how that works. We can simply use parseInt, either wrap this right around this prompt function here, which would work, or for readability's sake, do it right here on chosenMaxLife, where I then use parseInt on my entered value. So the entered value here, which is a string, is forwarded to parseInt. Now, of course, the user could have entered any kind of garbage here, for example, a string which is not convertible to a number. And therefore, here we can add a if check, and you can do that here as well, not just inside of functions, but also directly in the script, and check if the chosen max life here is maybe not a valid number. And for that, you can use a number function built into JavaScript, and that's the isNaN function, which checks if that is not a number. And parseInt will yield not a number, so this special NaN type, if you remember, if the value you pass to it, so entered value in this case, is something that can't be converted to a number. Then it will spit out NaN as a value, which is then stored in chosenMaxLife. And with isNaN, we check if that's the case. So if chosenMaxLife happens to be not a number, so this NaN special value. If that's the case, I'll set chosenMaxLife to my default of 100, so that we still have a working value for the game. We then don't use what the user entered, because that was unusable. Instead, we use our default value here. I also want to step in if the user sets the life here to a negative value or to 0. So we'll add the OR operator here and check if chosenMaxLife is smaller or equal than 0. That means that I also reset this to 100 if the user entered a too low life. Now, one important note regarding the order of evaluation here. JavaScript works such that it first checks this here if you have the OR operator. And if this yields true, since OR wants one of the two values to yield true overall, it doesn't even look at that second check here. So if we have chosenMaxLife, which is not a number, it won't even try to do that comparison, which is great because for this comparison, we need chosenMaxLife to be a number. But it will not even try to do that if this already tells us that it is not a number. So that's really good. It will stop for the OR operator after the first subcondition that returned true. If you had AND here, it would always look at both, because obviously for AND, both need to return true. But for OR, it stops after the first one that yielded true. So if we don't have a number with which we can work, it will not even try to do this check here. Now, in either case, we set chosenMaxLife to 100, and therefore now we give the user a chance of initializing the values here. So if I save that and I reload, now we get that prompt, and if I enter 80 here, and I then inspect these health bars, you will see that indeed max and value is set to 80 here. If we now attack, you see this decreases to lower values, and at some point we won. Then we can start another new game and we won again because I'm spamming the strong attack. Obviously, this game is not really balanced. By spamming strong attack, you will very likely win every game, but it's more about practicing if statements than building the next best amazing game, which will win you tons of money. You will have to do that on your own, unfortunately. So that works. If I reload and I set a different value, like let's say 200, you see it takes 200 as a value here, and therefore, of course, the game takes way longer. The health bars take way longer to shrink. If I reload again and I set this to 5, obviously then one hit is enough to win. And if I set this to, let's say, -10, You said we end up with 100 because then we overwrite the user choice because of the invalid values here. Now, by the way, if we press cancel here, we also go with the default values because that also doesn't yield us a valid number in the end. So with that, we got these basics down. Now, there's certainly more we can tweak and more we will do in this section. For example, we're also not doing anything with the show log button because we're not writing a log at the moment. But the basic game logic is implemented, and we have a couple of examples for if checks, also with this special isNaN function here, and lots of combinations of conditions, lots of different checks. So our game is taking shape. The logging functionality is still missing and we'll add it soon. Before we do that, I want to show you one pattern which you also sometimes see in code, or which you might want to use if you're having an if condition where you're using some kind of identifier, as I'm doing it here with the mode in attack monster. There we got attack and strong attack as values for which I check here. Now that means that in this case, since we received it here as a parameter in this function, we need to make sure that whenever we call that function, we do pass in attack or strong attack written exactly like this. And a simple typo like this already will break our function. Now obviously we can always find and fix such a typo thereafter, but you might want to avoid code where you use string identifiers like this, where you then can mistype. Now, that does not mean that you should avoid string identifiers altogether. There's just a more elegant way of handling them, and that's exactly what I want to show to you now. What you can always do is you can create some global constants. Let's say here at the top of our file, doesn't technically have to be there. It just should be done before you start using these constants. But having such global static constants at the top of your file quickly makes it possible for other developers to understand which key values this file uses, which key static values this file uses. And there we could create something like mode attack and store a string value of attack in there, or alternatively a number. So you could also have mode attack equal to 0, let's say, and also have mode strong attack, where you then store strong attack in there. Or if you work with numbers instead of string, mode strong attack might be 1, so a different number than for the normal attack. Now what's the idea behind these constants? The idea is that you can use them in your if condition down there and also when you call the function. Because now instead of comparing mode to a hard-coded string here, we can compare it to mode attack. So to this constant, which of course holds such a string. The idea is that we therefore only type the string once up there, and even if we do mistype here, that doesn't really matter therefore, because thereafter we only refer to this constant in all the places where we want to use this identifier, and therefore we avoid that danger of mistyping. So here I refer to mode strong attack, and therefore now when we call the function, we pass in mode attack and mode strong attack. And it's way harder for us to mistype the variable or the constant name here, because here we get some IDE support and therefore we avoid this extra error source. So with that, our code still works exactly as before. It just should make it easier for us to ensure that we avoid dumb mistakes or dumb typos, which might cost us minutes or hours to find and fix. Let's now work on the logging functionality. And there I want to log every round that happened in the game, every event that happened in the game. So when we attack the monster, when we launch a strong attack, when we heal ourselves, when the monster hits us, and also when the game is over. And for that we can add a new function, maybe up there, which I'll name write to log, because that's what's going to happen in there. Now in this function, the idea is that we write the different events to a log, and for that we of course also need a variable that holds our log. So here at the beginning of our file maybe we can add a new variable, battle log, and initially that's an empty array, let's say. Now I want to add entries to that array in the write-to-log function. For that, it would make sense to expect some kind of event parameter, event identifier, which describes the event that happened, and then have multiple if and else if blocks to check for the different events we want to support. Now, just as in the last lecture with the attack modes, which I set up as global identifiers, I want to do the same for my log events so that we avoid typos. And there I can have my log event player attack, for example, and give this an identifier of player attack, or use a number instead of a string. That's really up to you. Have my log event player strong attack with a text of player strong attack, let's say. Now these texts, as well as the variable or constant names here, are totally up to you. Of course, I just try to describe what we'll use them for. And I use this uppercase only notation here to make it clear that these are static values I, the developer, define here, hard code here at the beginning of my script. Then I also want to have a log event monster attack, of course, because the monster may hit us like this. And also a log event player heal, because we might heal, and also a log event game over, something like this. Now that could be the log events with which we want to deal, and therefore now we can check for them. We can check if event is equal to log event player attack, let's say. And if that is the case, I want to add a new entry, a new object to my battle log, which holds some information about that event. So for that, I'll actually create a new variable inside of the write-to-log function, so which is only available inside of that function, and that's my log entry. And then here we can set log entry equal to a new object. And in that object, I want to have my event identifier, which is a human readable string. And actually, therefore, here I prefer having a string identifier as we set it up here over a number, because later when we print that log to the console, for us humans, it's easier to see which kind of event that was if we have a string that describes the event than if we have a number which we then have to translate with the help of our code to find out which event that was. So here I store the event. Then I also want to store the value for the event, let's say, so the damage caused. So that's probably also something we should get here as an argument. So I'll expect a value here, a value argument, and store that in my value prop here. And in case it's confusing for you that we have the same names for the keys as for the values here, of course you could get, let's say, EV here and a val, and then use EV here and val here to make it clearer that the key names are totally detached from the value variable names here. So now I'm storing the event, which is something like player attack, the value for that event, which for the player attack would be the damage dealt. For player heal, it would be the damage for which you healed. For game over, it could be the name of the winner, so player or monster, for example. And I also want to output the final monster health here. And for that, I can access the current monster health. Alternatively, we also expect this as an argument here, which might be cleaner. We could use the global variable, but by using an internal parameter, we make this function a more pure function, which only works with data provided to it, instead of also taking some global value, which is always kind of dirty or harder to follow if you're reading the code. It might be unexpected that a function also pulls in some information from outside, especially if it's a function that also does take parameters. And also the final player health here maybe. And for that, I also expect to get my player health snapshot here and store that. So that could be a log entry we want to create, and then we can reach out to the battle log and push that log entry onto the battle log. This is how we could add a new entry there. Now, of course, we don't just have that case that we have the player attack. We also have many other events that can occur for which we set up identifiers. So we can add another else if statement here where we check if event is maybe equal to log event player strong attack, let's say. If that is the case, I will basically create my log entry in the same way though. So therefore actually we don't really need else if block here, right? Because we only populate the log entry with the data we got here. Well, that's indeed true. You could totally create that function without any if checks if log entry is always created in the same way with dynamic data that changes when you call the function but not inside of the function. To again practice if statements, I will add some extra information here which depends on the event that occurred. I want to say target and here say monster. That's some information we're not getting from outside. Here I'll also add target monster.